Welcome to G Fun Facts Online. Today, we're setting sail into the deep past, exploring an ancient engineering marvel that allowed humanity to conquer the oceans long before the age of steam and steel. This is the story of shell-first shipbuilding, a revolutionary technique that laid the foundation for global trade, exploration, and cultural exchange. From the Nile to the North Atlantic and across the vast Pacific, ancient shipwrights, without blueprints or modern machines, crafted vessels of incredible strength and resilience, fundamentally changing the course of human history. The core idea behind shell-first construction is deceptively simple. You build the outer skin or the shell of the ship first. Only after this watertight hull is complete do you add the internal skeleton of frames and ribs for reinforcement. This is the exact opposite of the frame-first method that dominates shipbuilding today, where a skeleton is built first and then covered with a skin. Shell-first wasn't just a building method, it was a philosophy, one that relied on the inherent strength of the wood and the immense skill of the craftsman to create a vessel that was both strong and flexible. This global story has many different chapters, as cultures all over the world developed their own unique variations, perfectly adapted to their needs and the materials they had on hand. Let's begin our journey in the ancient Mediterranean, home to the masters of the mortise-and-tenon joint. This technique involved meticulously carving a slot, called a mortise, into the edge of one plank, and a corresponding tongue, or tenon, on the plank next to it. These were fitted together, often secured with wooden pegs, creating an incredibly strong and rigid hull, almost like a single piece of carved wood. The ancient Egyptians were among the earliest pioneers. The most spectacular example is the Khufu ship, discovered sealed in a pit near the Great Pyramid of Giza, and dating back to around 2500 BC. This is not some small riverboat. It's a colossal vessel, over 140 feet long, built from massive cedar planks. The builders joined these planks with thousands of unpegged mortise and tenon joints, and then stitched the whole structure together with ropes made from half-a-grass. They constructed the entire outer shell before inserting the internal framework for support. While this specific ship was a ceremonial solar bark, meant to carry the pharaoh in the afterlife, the discovery of other vessels, like the Abydos boats, shows this was a well-established Egyptian tradition. These ships prove their advanced woodworking skills and their deep cultural connection to the water. The Greeks and Romans also became masters of this method. A fantastic window into their world is the Kyrenia ship, a Greek merchant vessel that sank off the coast of Cyprus around the 3rd century BC. It was remarkably well preserved, and its hull shows the classic shell-first technique, with mortise and tenon joints spaced very closely together. This created a robust hull capable of hauling heavy cargoes of wine and olive oil across the Mediterranean. Even earlier evidence comes from the Uluburun shipwreck, found off the Turkish coast, which dates all the way back to the Late Bronze Age. This shell-first ship carried a treasure trove of cargo from at least 7 different cultures, including copper, tin, ebony, and ivory, revealing just how extensive and sophisticated trade networks were thousands of years ago. The Romans, who started as a land power, learned shipbuilding from the Greeks and Carthaginians, eventually using this technique to build the fleets that made them a formidable maritime empire, before they slowly began a transition to frame-first construction centuries later. Now, let's travel north, to the cold, harsh waters of the North Atlantic, the domain of the Vikings. Here, a completely different, but equally effective, form of shell-first construction evolved, the clinker-built method, also known as lapstrake. Instead of fitting planks edge to edge, the Vikings overlapped them, like shingles on a roof, and fastened them together with iron rivets. This created a hull that was both incredibly strong and remarkably flexible, able to twist and bend with the violent waves of the open ocean. The iconic Viking longship is the ultimate expression of clinker construction. The process began with a solid keel, the ship's backbone. From there, shipwrights would build up the hull, plank by plank, carefully shaping each one to create the ship's elegant, curved form. Each plank was overlapped and secured, with rivets hammered from both sides. Only after the shell was complete were the internal frames fitted and fastened to the hull, often with lashings, which added to the ship's overall flexibility. The result was a vessel that was light, fast, and famously seaworthy, equally at home on terrifying ocean voyages and in shallow, navigable rivers. We know so much about these ships thanks to stunning archaeological finds. The Gokstad ship, a 9th century vessel discovered in a burial mound in Norway, is a magnificent, almost perfectly preserved example. Its overlapping oak planks and complex system of ribs reveal the genius of its design. Then there are the Skuldelev ships, a group of 5 Viking vessels deliberately sunk in a Danish fjord in the 11th century to block a channel. This collection is a snapshot of the Viking world, showcasing everything from a massive warship, nearly 100 feet long, to smaller, sturdier trading vessels and fishing boats. Our final stop takes us across the globe to the vast Pacific Ocean, where the Austronesian peoples developed yet another ingenious form of shell-first shipbuilding, the lashed-lug technique. This method was the key that unlocked the Pacific, enabling one of the most remarkable human migrations in history. Instead of metal fasteners or complex joinery, this technique involved carving raised features called lugs or cleats on the inside face of the hull planks. These lugs had holes drilled through them, which allowed the planks to be literally sewn together edge to edge and then lashed to the internal ribs using ropes made from strong natural fibers like coconut husk. The process often began with a dugout canoe forming the base of the hull. Planks were then built up on the sides, stitched at the seams, and then the entire structure was cinched tight to the ribs via the internal lugs. This created a strong, yet flexible hull that could absorb the stresses of long ocean voyages without relying on a single piece of metal. It was an elegant solution, born from the resources of the island environments they inhabited. Archaeological evidence for these lashed-lug boats has been found throughout Southeast Asia and the Pacific, confirming this was the technology that carried the Austronesians from Taiwan to Easter Island, Madagascar, and New Zealand. So how exactly were these ships built? While the techniques varied, the fundamental steps were surprisingly consistent across these ancient cultures. It all began with the foundation. This was usually a keel, but could also be a dugout log, as we saw with the Austronesians. From there, the shipwrights would build the hull upwards, plank by plank. The skills required were immense. In the Mediterranean, craftsmen used saws, axes, adzes, and drills to precisely shape the cedar and pine planks and cut the thousands of mortise and tenon joints needed for a tight fit. The Vikings, using their clinker technique, relied on axes and adzes to split and shape oak planks, following the natural grain of the wood to ensure maximum strength. They used draw knives to smooth the planks and augers to drill the holes for the iron rivets. The Austronesian shipwrights were masters of carving, shaping the lugs on the interior of the planks with incredible precision, knowing that the structural integrity of the entire vessel depended on their lashing points. Once the outer shell was complete, the internal framework was added. Ribs and crossbeams provided the necessary reinforcement. In the Mediterranean, these frames were often pegged or nailed directly to the hull planks. But for the Vikings and Austronesians, flexibility was key. The Vikings lashed their frames to the lugs on the planks, a feature that allowed their longships to flex in rough seas. The Austronesians, of course, used their signature lashed-lug system to secure the ribs, creating a similarly resilient structure. With the main construction complete, the final critical step was waterproofing. The Egyptians smeared a mixture of resin and bitumen into the seams. The Vikings caulked their ships by stuffing tarred animal hair or wool into the gaps between the overlapping planks. Finally, the vessel was equipped for propulsion. This could be a simple set for oars, or a complex mast and sail rig, an entire science in itself, designed to catch the wind and power these vessels across the waves. For millennia, shell first was the undisputed king of shipbuilding. But around the end of the first millennium AD, things began to change, particularly in the Mediterranean. A new method, frame-first construction, began to take hold. This transition was gradual, driven by economics and technology. The frame-first method, building the skeleton first, was more systematic. It allowed for a more efficient use of timber, as planks didn't need to be as perfectly shaped. It also meant you could build bigger ships and standardize designs more easily. While the shell-first method demanded a master craftsman to shape every single piece, the frame-first approach allowed for a more specialized workforce, streamlining the entire process. Despite its eventual decline in many parts of the world, the legacy of shell-first construction is monumental. The archaeological remains of these ancient vessels, from the majestic Khufu ship to the rugged Gokstad longship, are time capsules. They are a direct, physical link to the ingenuity of our ancestors. They reveal the secrets of an engineering tradition that connected the world and set humanity on a new course. The principles of strength, flexibility, and resilience embodied in these ancient wooden hulls continue to be a timeless tribute to the enduring power of human innovation.